Hello, and thank you for joining me. My name is Andrew Rams, and I am a field application scientist with PinAAcle. Today I'd like to talk to you about the PinAAcle 500 Flame Atomic Absorption Spectrometer, which is an ideal partner for you in your precious metal analyses. But before we talk about the newest Flame AA in PinAAcle, let's talk about the history of PinAAcle and atomic absorption. It starts all the way back in 1961 when PinAAcle introduced the Model 214. It was a Flame AA, and it was quite rudimentary compared to what modern AA instruments are. Now, through the years, we've introduced many innovations in flame atomic absorption as well as graphite furnace atomic absorption. We get all the way up to our current state with the new PinAAcle series, which was introduced beginning in 2011, and the PinAAcle 500, which was introduced in 2014. Over 50,000 AA instruments have been sold since the first instrument was produced in 1961. So we have a long history with PinAAcle with this technology. Here is the full PinAAcle AA family. On the far left, you've got the PinAAcle 500, which we'll talk extensively about in the continuing slides. Next to it is the PinAAcle 900F, which is the big brother to the PinAAcle 500. It is a flame-only unit as well. It also includes deuterium background correction, and it has a larger lamp turret compared to the PinAAcle 500. It can contain up to 8 lamps at one time, whereas the PinAAcle 500 is limited to 4 lamps. The other benefit of the PinAAcle 900F is that it has full motorized adjustment of the burner height and depth to allow quick adjustment and optimization of the burner position. Next is the PinAAcle 900Z. This is a transversely heated graphite furnace. It includes longitudinal Zeeman background correction for optimum background correction, and includes its own built-in auto sampler. Next is the PinAAcle 900H. This is a dual purpose unit. It has both flame and HGA furnace. Again, this has deuterium background correction, and because it is an HGA unit, it does not include the Zeeman correction on the furnace. And finally, we have the PinAAcle 900T, which is another dual unit, but this time it is a flame combined with a THGA furnace. So this does include the full Zeeman background correction on the furnace, as well as the deuterium background correction on the flame. So without further ado, let's get into the benefits and features specifically for the PinAAcle 500 Flame AA. So special attention has been made to help the PinAAcle 500 with longevity in environments typical of Flame AA, namely exposure to solutions with high concentrations of acids. These instruments tend to not have the greatest environments to work in, so we've tried to introduce a lot of corrosion-resistant aspects to them. So some of the exterior benefits include a polymer-coated flame shield, corrosion-resistant solid titanium burner heads, and a polymeric sample introduction module, which we'll get into further details in the coming slides. But it's not only the exterior that has had special attention to corrosion resistance, but the interior as well, with conformally coated circuit boards to protect against moisture, dust, and acid fumes. And you may be asking, or you may not have heard of what conformally coated circuit boards are, but a conformal coating is a protective chemical coating or polymer film that conforms to a circuit board, and it's there to protect the circuitry from harsh environments that may contain moisture or strong acids that can affect the circuitry. So this is just a good way to keep the internals of these flame AA units lasting as long as possible in these harsh environments. Now, it's not only the circuit boards that had special attention paid to them in this latest introduction, but also the PinAAcle 500 introduces fiber optics within the system as well. So we've gone with fiber optic cables throughout the system, replacing a lot of the mirrors that we used to have in our older systems. The benefits of fiber optics are that they provide high light transmission, and they also have a side benefit of needing less cleaning and maintenance because a fiber optic doesn't really get dirty over time. So the benefit is you get better light transmission with minimum maintenance. So it's a win-win situation. To give you a better idea of how the fiber optic bundles are used within the system, this diagram should help demonstrate that. The optical system design utilizes fiber optic cables throughout the system, as you can see. The PinAAcle AAs have a real-time double beam system along with the solid state detector with dedicated areas for sample and reference beams. The use of a new optical design and the solid state detector allows the simultaneous measurement of the sample and reference beams for true double beam operation in flame mode. Background correction is performed using a high-intensity deuterium arc lamp as the continuum source. This provides fast startup, exceptional long-term stability, and optimum analytical performance for flame. As I alluded to on the previous slide, the PinAAcle 500 uses a solid-state detector. Now, the benefits of a solid-state detector compared to the alternative, which is using a photomultiplier tube, marked as PMT in this slide, is that the quantum efficiency of a solid-state detector is far greater across the entire spectrum. We can even illustrate this looking at an example of nickel at 232 nanometers. Now, the slide or the picture on the left is a real-time signal of the nickel, but using the solid-state detector. Now you can see the scale on both of these, the one on the left and the one on the right, is the same. So we're going from 0 to an absorbance of 0.01. The noise coming from the photomultiplier tube system is far greater in amplitude than the one on the solid-state detector. So that should show you dramatically why this is a good development to have. The other benefit of the PinAAcle 500 when we take into account the new optical system, the solid-state detector, and all the other optimizations is that this leads you to better detection limits overall. So we can look at some selected elements here and compare it to different competitors with what they've shown as results publicly available in application notes. Is that the PinAAcle 500 has the same or better detection limits across a wide range of elements. So this just shows that the system definitely has been optimized optically for the superior performance. One of the other aspects that makes the PinAAcle 500 unique and quite usable is that the lamps are very user-friendly. They come with a 5,000 milliamp hour or 2-year warranty. They all have lamp life indicators within the software. We do sell coded lamps for self-recognition. So the software will pick up what lamp is plugged into which location within the lamp turret. We'll also be able to identify that lamp by its serial number and also tell the user how many milliamp hours are on that lamp. We also have a very large selection of single and multi-element lamps available within PinAAcle to help you meet whatever needs you have for elemental analysis on your flame AA. All PinAAcle flame AA instruments include a pre-mix burner system. This high-strength, inert plastic burner chamber is angled for proper drainage and includes an adjustable nebulizer, either a high sensitivity nebulizer as depicted in this picture, or a stainless steel nebulizer. We would also include with these systems a standard titanium 10 centimeter single slot burner head for air acetylene operation. Now these burner heads are easily cleaned. They are inert because they are made of solid titanium block, and they are available to be used with a wide range of sample matrices, and they all come with a lifetime guarantee under normal use. Now the system has many wonderful hardware benefits, but what the users are going to be using most is going to be typically interacting with the software. So with the PinAAcle 500, you have the option of using either a touch-based simplified software or the full Syngistix software. It's up to the user which they would prefer to use. Now let's talk first about the Syngistix Touch software. The PinAAcle 500 has the unique benefit of running the Syngistix Touch software along with an integrated touchscreen. When you open the software, you are presented with a periodic table. This periodic table will show you all the possible elements that you could use, the Flame AA for analysis. If you have any methods already created, you will see that the element is listed in a purple color. So if the user wanted to, in this case, select copper, there is a method available. So let's pretend that the user has clicked on copper. Now here we can see that the list of methods available for copper includes one method so far. If the user wanted to create a new method, there is a new method button in the top right-hand corner. You could click on that and create your new method and set up all the parameters. But in this case, let's select the currently pre-made method that is available. And we would click on the Analyze button right next to the New Method button in the top right-hand corner. Once you have clicked on that Analyze button, you would be presented with this final screen. So this screen will show you a real-time continuous graphics screen in the top left-hand corner. In the top central area, we would have a updated calibration curve. So in real time, as you're analyzing calibration standards, we'll update your calibration curve and give you your correlation coefficients. And then in the bottom portion of the screen, well, middle bottom portion, you'll have a full list of all the samples that you have analyzed, along with the replicates, the RSD, the standard deviation, and the mean. And then the bottom portion of the window, you'll have all of the functionality buttons. So turning your flame on or off, checking that all safety interlocks are satisfied. You can choose to run in both manual and automated mode. So if you have a auto sampler connected, you can use that as well. In manual mode, then you will be able to select Analyze Blank, Analyze Standards. You can choose from a list of your standards and the drop-down list right next to it. You can also click the Analyze Sample button and enter manually as you're analyzing the names of the samples, or on the far right-hand side in the status panel, you can see that there is a method listed, but there's also sample information file listed. If you were to click on that, it would open up your sample information file, and you would be able to make a pre-list of all the samples you intend to run so that you don't have to type them out manually as you're running them. Down below, there's also an option to print. You can change methods, you can go back to the home screen, and you can also access the settings screen all from this. So the benefits here are that we like to say it's 3 clicks from setup to analysis. So it is a very simplified workflow, but it's there to make life a little bit easier for routine analysis. Now I mentioned that there is printing, so we can print either directly to a physical printer or create PDF copies of this report screen. So you can see in the report screen, it's very similar to what you might be used to if you've used WinLab or Syngistix software in the past. We would also include in these reports the calibration curves, but all the standard information there is already available. For users who require more sophisticated controls, the full version of Syngistix for AA software is also compatible with the PinAAcle 500, allowing the use of more advanced settings and pairing of upgraded autosamplers. And we'll talk about upgraded autosamplers in a few slides, but just to show you some of the benefits of the full Syngistix software, you can see that in the top portion, it is more of like a ribbon style toolbar, similar to what you might find in Microsoft Office products, where all the buttons are available. You don't have to search through drop-down lists. As well, we have a more full-featured analysis window, combines manual and automated analyses at the switch of a tab, along with a list of your progress through your list of samples. We have our status panel on the side, again with quick links to all of the methods, sample information file, dataset files. But let's talk more now about the automation portion of what we can do with a Flame AA and more sophisticated autosamplers. So we call these fast flame sample automation. So there's 3 different systems. There's the AAPrep 2 system, the Fast Flame 1, and the Fast Flame 2. These are all designed to help you with your throughput and your analysis in different ways. For the AAPrep 2, it's more than just an autodiluter, they say, just because obviously the system will do dilutions for you, whether they're prescriptive dilutions, where you know ahead of time what your concentrations are and what dilution factor you'll need to apply to each sample. You can enter that into the sample information file ahead of time. Or if the sample is going outside of your calibration range, you can have the autosampler auto-dilute to bring it back into a range that fits within your calibration range. And the more than an auto-diluter portion is that it can also do inline auto-calibration from a single stock solution. So in the bottom right-hand corner, there's an example of looking at a single solution where we have started with a 4 milligram per liter standard, and we have diluted that multiple times to create a calibration curve. For users that require high throughput and aren't as concerned about doing dilutions with their autosampler system, then we have the Fast Flame 1 solution for you. The Fast Flame 1 consists of a system of a switching valve and a single peristaltic pump, whereby a vacuum system is loading a sample loop, then switching the switching valve and using the peristaltic pump to drive a carrier solution at a known flow into the flame. Now, this system allows for very quick throughput. We can run up to 560 samples per hour with an acquisition time of 6.4 seconds per sample, making the bottleneck purely in how fast you can actually prepare samples for your Flame AA. If you're worried about the stability of such a high throughput system, let me put those worries to rest right now. Here's a short-term stability study where we analyzed 1,000 replicates of a 2 ppm copper solution. Now our throughput here was about 8.2 seconds per sample. It took just over 2¼ hours to read these 1,000 samples, so it's a little over 2 hours. But the RSD for this entire run was only 1.8%. So very stable readings over that slightly longer than 2 hour run. And if 2 hours isn't enough to convince you, here's a longer term stability run. Same type of solution. It was a 2 milligram per liter copper solution, but we ran it over 20 hours. So in this system, or in this test, we actually analyzed 8,931 replicates, and the RSD was only 2.1% over those 20 hours. So again, great stability. And last but not least, we get to the FastFlame 2 system. For those of you that need both high throughput and auto dilution capabilities. The FastFlame 2 combines the switching valve from FastFlame 1 and the dual peristaltic pump solution from the AAPrep 2 system. So this will allow us to do both the high throughput using a vacuum pump and the switching valve, as well as having the dilution capabilities with a dual pump peristaltic pump. Now that I've discussed with you many of the benefits and features of the PinAAcle 500 Flame AA, I'd like to take this time to show you some data from a real-world geochemistry application. Flame AAs are commonly used in the analysis of precious metals. And one of the most common ways to prepare a sample for precious metal analysis is the use of the classical fire assay technique, whereby you're going to use 30, maybe 50 grams of a crushed rock. You're going to mix that up in a lead oxide, you're going to add some borax, maybe some silver nitrate. You're going to put that into a blast furnace. You're going to let all that lead combine with the precious metals. It'll form a lead button. And you're going to put that in capels to remove the lead. And you're left with a metal-free, or a matrix-free, I should say, metal bead called a prill or a doré bead. You're then going to take that bead. You can either do a gravimetric analysis on that, or you can dissolve that in acids for analysis by Flame AA or some other techniques. Now, Flame AA is a very fast, simple, and low-cost technique to analyze the metal bead because it's highly accurate and because the analyte content within these beads can be quite varied. So it's very easy to back calculate results and determine metal concentrations in the ore from a digested sample read on a Flame AA. So for this study, since we did not prepare the fire assay samples ourselves, we decided to simulate this by preparing samples from single element standards diluted in appropriate acids. So for the precious metals, the gold, platinum, and palladium, we put those into 15% aqua regia. And then for silver and copper, since these are commonly of commercial interest, we also include that in the study as well. Typically, you wouldn't be studying silver from fire assay results because you are adding silver to that process most of the time. For our calibration standards, they were all external calibrations. Obviously, we didn't have real samples, so we couldn't have done a method of standard addition and spiking into them. But here, for the external calibrations, the lowest standards all gave RSDs less than 5%, and you can see the calibration ranges below. And everything was set to a calibration type of linear through 0. To show you what the conditions were on the PinAAcle 500 for this test, here are two tables describing what wavelengths, slits, lamps, airflow, and settling flows were used. Now for all these tests, we were using a high sensitivity nebulizer with the spacer removed, and we were using self-aspiration, not an auto sampler. For all these gold, or all these metals, not just gold, we are actually optimizing the flame conditions, so the gas flows, both the airflow and acetylene, to maximize our signal and stability. And here are the calibration curves. So we had linear curves for all of these, and the R squared for all curves was greater than 3 nines, showing the accuracy of the system. And as well, we created some mid-level standards since every calibration curve contained 4 standards. We chose the mid-level of each one of those curves, created a new standard, and tested the readback on those. So you can see the results in this table here, where our recoveries were all within very tight margins. So in summary of this application, I hope that we demonstrated that the PinAAcle 500 AA is usable for accurate low measurements of precious metals. It also demonstrated the ability to optimize the flame conditions for each element individually. And we also showed the accuracy with low-level calibrations and standard readbacks. Well, thank you very much for sticking with me through this talk. I appreciate you joining me, and I hope that I was able to demonstrate the features and benefits of the PinAAcle 500 Flame AA as a great addition to any geochemistry lab. Thank you.